Now explaining properties of a determinant. Say first property. Property I am explaining by example. Suppose we take a determinant. A determinant, I say D. D is, suppose determinant is 1, 2, 3, 0, minus 1, minus 2, 1, 4, 0. As for example, we are taking this determinant. Now, finding its value is 1 into 0 minus minus 8, that is plus 8, minus 2 into 0 minus minus 2, that is plus 2, plus 3 into 0 minus minus 1, that is plus 1. So this is 8 plus 3, 11, 11 minus 4, 7. Value of this determinant is 7. Now what I do, I am interchanging these rows into columns, means converting these 3 rows into corresponding columns. So by this operation, converting all rows into corresponding columns, all the rows are converted into columns, or we can also say all the columns are converted into rows. We get new determinant D dash is, first row is now first column, second row is second column, third row is third column. So all the rows are converted into corresponding columns. Now let me find value of this determinant. So 1 into 0 minus minus 8, that is plus 8. Then minus 0 into anything 0. 1 into minus 4. Minus 4 plus 3, that is minus 4 plus 3, that is 1. So 1 into 0 minus minus 8, that is plus 8. Then 1 into minus 4 plus 3, that is minus 1. Sorry, here it is minus 1. Minus 4 plus 3, that is minus 1. So 8 minus 1 is 7. So you can see that here value of new determinant is 7. Value of given determinant is also equal to 7. So values are same. So we can say that if all the rows of any determinant are converted into its corresponding columns, then value of given determinant remains unchanged. So I am putting this statement that value of, if all the rows of given a determinant are converted into its corresponding columns, then the value of determinant remains unchanged. So whenever we will perform this procedure, this operation, then we keep value as it is. Now second property. Suppose I am taking same determinant D. Now to explain second property, what we do here, suppose I take here D dash. D dash is, I am interchanging any two rows. Interchanging any two rows. Say here, again I am rewriting D. D is same determinant. Its value already found, 7. Now any two rows, suppose I am interchanging first and third row among themselves. So interchanging first and third rows among themselves, new determinant is D dash is equal to, say here in first place third row comes and in third place first row comes. So interchanging first and third rows among themselves, this is the new determinant. Now let me find its value. So 1 into minus 3 plus 4, that is 1, minus 4 into 0 minus 2, that is plus 2. So 1 minus 8, that is minus 7. So D dash is minus 7 and this is equal to minus D. So D dash is equal to minus D, that means D dash plus D is 0. So whenever we interchange any two rows among themselves or any two columns, it is not true only for rows. If you interchange first and third column among themselves, first and second column among themselves, then also value of new determinant is additive inverse of given determinant. So that is second property. If any two rows or columns are interchanged in given determinant, then value of new determinant is the additive inverse of given determinant. So that is second property. So whenever applying these rules in any determinant, as we change value, as we interchange any two rows or any two columns, then its value, it will be minus of given determinant. Means value, its sign will be changed. Then third rule, suppose here we take determinant to, I am taking same determinant, suppose 1 0 1, 1 2 3, every time we are taking this simple determinant, 0 minus 1 minus 2, 1 4 0, its value is 7. Now in this determinant, suppose I keep any two rows identical. Suppose I am taking 1 2 3, first and third row identical, so value will not be 7, it will be changed, new determinant. Now if we find its value, then 1 into minus 3 plus 4 minus 2 into 0 minus minus 2, that is plus 2, plus 3 into 0 minus minus 1, that is plus 1. So this is 1 minus 4 plus 3, that is 0. In any determinant, if any two rows are identical, then always its value is 0. No need to find by expansion. No need to expand the determinant. Direct you can put value is 0. And it is not true only for two rows. It is also true for any two columns. So if any two columns are identical, then also value is 0. Any two rows are identical, then also value is 0. So if rule is, if any two rows or columns A given a determinant are identical, then its value is 0. So that is third property. Now going on fourth property. Now fourth property, to understand this fourth property, again I am taking one example. Suppose a determinant is 1 minus 1 2 0 minus 2 1, suppose 4 1 0. This is a determinant. We are taking simple determinant, so we can calculate easily. Now its value is 1 into 0 minus 1, then plus 1 into 0 minus 4, plus 2 into 0 minus 8, that is plus 8. So again see 1 into 0 minus 1 plus 1 into 0 minus 4 plus 2 into 0 minus 8, that is plus 8. So 16 minus 5 is 11. So value of D is 11. Now what we do? Now I am multiplying elements of, suppose I select any one row or any one column. Suppose we select row 1. Now what we do in row 1? Multiplying elements of row 1 by some number. Suppose I multiply by 3. So this will be 3 into R1. So elements of R1 are multiplied by 3. So by this operation, D dash is equal to, say here, 3 minus 3 6. Instead of that, if you want to multiply elements of third row by 3, multiplying elements of third row by 3 or by 4, suppose third row we multiply by 4, select any number, any real number can be taken here. Multiplying elements of third row by 4, so first row as it is, second row as it is. Elements of third row I am multiplying by 4, so this will be 16 4 0. And now we calculate this value. This is equal to, so 1 into 0 minus 4 plus 1 into 0 minus 16 plus 2 into 0 plus 32. So this is minus 20 plus 64. So this is 44. Now see what happened here. D dash is 44. It is 4 times 11. So value becomes 4 times because this row was multiplied by 4. If it was multiplied by 5, then it will be 5 times 55. If you multiply third row by minus 2, then this will be minus 2 times, so minus 22. So that means if any row or any column is multiplied by some constant k, then value of a new determinant obtained thus, it will be k times value of given determinant. So that is the property. So here d dash is equal to 4 times d. D dash is k times d. So putting this property in words, if any row or column is multiplied by k, any constant k, then value of new determinant obtained thus equals to k times value of given determinant. So see, when doing questions, what we will do here, this is d. See, we shall perform this procedure: 1 minus 1 2, 0 minus 2 1, 4 1 0. What is its value? 11. So that means what I have written? I have written d is equal to 11. This is d equal to 11. Now in the next step, if I multiply elements of third row by 4, 16 4 0, first and second row as it is, then what happens? I have written 44. So this is what? 44. So multiplying third row by 4, now this value I cannot connect by sign of equality. Here I am not allowed to put this sign because 11 is not equal to 44. If you want to join them by sign of equality, these numbers, then I have to multiply by 1 upon 4. So here if I want to multiply this by sign of equality, then see, this is 11, this is 44, so sign of equality is allowed if you divide this by 4. That means whenever doing a questions, what we will do, whenever you multiply any row or any column by 4, then in the next step, whatever you get a new determinant, divide by 4. If you here multiply by 5, here divide by 5. If you divide by 5, then multiply by 5. Dividing any row or any column by 5, that means you are multiplying by 1 upon 5. And whenever you multiply by any number k, then in the next step, divide by k. So here divide, here multiply. If here multiply, here divide. So this will be the way of application of this rule when doing questions. Now next rule is fifth rule. Suppose I take a determinant d. Suppose I am taking same 1 minus 1 2, 0 minus 2 1, 4 1 0. We know that its value is 11. Its value is 11. This is 11. Now here I am multiplying elements of third row by 2 and adding products into corresponding elements of a first row. These elements I am multiplying by 2 and whatever is product I am adding in first row. So say here new determinant is 4 into 2, 8, add here 8. So 8 plus 1, 9. 1 into 2 is 2, add here 2 minus 1 is 1. 0 into 2 is 0, add here 2 plus 0 is 2. So this operation we show by this symbol that here in the first row entries are changed. What is change done in first row? In first row what we have done, third row is multiplied by 2 and values are added in first row. So this is the change in first row. So by this operation we are getting this determinant, that in first row what is done, in first row elements of third row after multiplying by 2 products are added. So change is in first row. Second and third row keep as it is. Now let me check its value. This is equal to 9 into 0 minus 1 minus 1 into 0 minus 4 plus 2 into 0 minus minus 8, that is plus 8. So minus 9 plus 4 plus 16. 16 plus 4, 20. 20 minus 9 is 11. D has value 11. Value of D is 11 and value of D dash is also 11. So here D is equal to D dash. Here D is D dash. Value remains unchanged. Here I multiplied third row by 2, then added in first row. Instead of 2, if you multiply this value by 200, 2000 or multiply by 2 crore, then add products in first row, then these numbers will be in crores, but value of determinant remains 11. Value remains unchanged. So this is the property. Putting in words, if elements of, if any row or column, this can be also performed in column instead of row. If I take column, multiply third column by any number k, add in first column or add in second column, value remains same. So if any row or column is multiplied by k and added in to some another row or column, then value of new determinant remains unchanged. So this was fifth property. Now sixth property. Sixth property is property how to add values of determinant. That is sixth property. Regarding addition of determinant, what is the rule for addition of determinant? Sixth property. Say, suppose here I take determinant 2, 1, 3, 4, minus 1, 0, 6, 7, 8 plus, suppose here 4, 1, 6 4 minus 1 0, taking 5 10 6, 4 minus 1 0, 6 7 8. We want to add these two determinants. Now here, if I add corner to corner, suppose 2 plus 5 7, 1 plus 10 11, 6 plus 3 9, 4 plus 4 8, minus 1 minus 2, 0 plus 0 is 0, 6 plus 6 is 12, 7 plus 7 14, 8 plus 8 16, then this is not correct. This is not valid. We can't add corner to corner. So what to do to add two determinants? Say here, whenever we add two determinants, first of all check whether in given two determinants any two rows must be same. Two rows or two columns on the same level must be same. Say here second row, here second row, in both second row are same, third row are same. So if such determinants are given, then first of all don't add second and third row. Second and third row keep as it is. Two identical rows keep as they are. Add unequal row which are of the same order, first row. So 2 plus 5, this is 7, 1 plus 10 11, 3 plus 6 9. So this is allowed. As for example, suppose here 2 minus 1 0, 4 6 8, 3 1 9 plus 2 4 3, 1 11 12, 0 8 9. Now look here. In these two determinants, first column are same, third column are same. Any two lines must be same. So whatever are columns and rows same, keep them unchanged. So 2 4 3 we keep as it is. We don't add similar columns or similar rows. Second columns are unequal, so we add a second column. So minus 1 plus 1, 6 plus 11, 1 plus 12. So this is correct. Addition is allowed in any one row or in any one column, not in every row, every column, and under condition that two lines, two rows or any two columns must be same. So this rule can be expressed as, suppose here A1 B1 C1, A2 B2 C2, A3 B3 C3 plus here I give A2 B2 C2, A3 B3 C3, here X1 Y1 Z1. So say these are equal. So equal rows we keep them as they are. We add elements of first row only. So A1 plus X1, B1 plus Y1 and C1 plus Z1. A2 B2 C2 keep as it is. A3 B3 C3 we keep as it is. So this is rule for addition of determinants. So now questions are based on these 6 properties, very important property. Now see, question is prove that this determinant is equal to 0. So here we are starting from left hand side. Left hand side is x, y, z, a, b, c, x plus a, y plus b, z plus c. See, this type of problems can be solved by many ways. There is no unique method. Here we want to show that this is equal to 0. That means it may be possible that any two rows or any two columns of this determinant will be identical. So we try to get any two columns or any two rows identical. So say, look the elements. Whenever we do such type of problems, always observe elements in columns. Also observe in this direction, first row, second row, third row, and get idea about proper starting. Starting is very important. So here this is x plus a, y plus b, z plus c. If we add elements of second column in first column, then first and third column will be same. So doing this here, say here second column I am adding in first column. So x plus a, y plus b, z plus c. A, b, c, x plus a, y plus b, z plus c. So what is done here? Here we perform this procedure in column 1. In column 1, second column is added. Means elements of second column multiplying by 1, adding in first column. Elements of second column are multiplied by 1 and adding in first column. That means simply we are speaking adding second and first column into first column. So when we perform this operation, value of new determinant remains unchanged. If its value is 11, value of this determinant will be also 11. So we join them by sign of equality. So this is equal to this determinant. D is equal to D dash. And now say here these two are same, so value is 0 because column 1 and column 3 are equal. Suppose we can also do by second method. No unique method. You can show by many ways. Suppose LHS is x, y, z, a, b, c, x plus a, y plus b, z plus c. Now look. Second row I am subtracting in third row, then A, B, C will be cancelled, and then first and third column will be same. That is second way to prove its value is 0. So it is equal to, this is equal to first column as it is, second column as it is, no change in second column. We are changing third column. In third column we are subtracting second column. So it will be then x, y, z. So what is done? Change in third column. In third column, second column is subtracted. That means subtraction means it is what? Which procedure we perform? It is, we can speak like this: elements of second column are multiplied by -1 and added in third column. So performing this procedure, value of new determinant remains unchanged. So if this is 11, its value is also 11. and now you can see that these two are equal, so its value is 0 because first column and third column are equal. So to show value of any determinant 0, show that any two columns are same or any two rows are same. So in this question, any two columns same can be done by many ways. Here two ways already I have shown. You can also think by third way. So therefore this is RHS. So LHS equal to RHS. This is true. Now in this question, left hand side is 2, 3, 5, 7, 8, 9, 65, 75, 86. We want to prove it is 0 without expanding. So here instruction is prove these all using property. Prove these questions using properties of determinant. This also we want to prove using property of determinant, not by expanding. So this is equal to, now see, we want 0. So try to get any two rows or any two columns to get identical. Now look here, this is 65, here is 7. If we multiply 7 by 9 and adding in a first column, so 63, 7 into 9, 63, 63 plus 2 is 65. So this is done. But we can't multiply any one element. Multiply whole column by 9. Add in first column. Look for, check for second. 8 into 9, 72. 72 plus 3 is 75. 9 into 9, 81. 81 into 5 is 86. So we are getting first and third column same. So here which operation we are doing? We are doing change in first column. In first column what we are doing? Elements of a second column multiplying by 9, adding in first column. So this is change. Change will be in C1. C1 will be changed by this operation. So here 2 plus 63, 3 plus 72, 5 plus 81. And performing such operations, value of new determinant remains unchanged. So whatever will be value of this determinant, same will be value of this determinant. So it is equal to 65, 7, 65, 75, 8, 75, 86, 9, 86. And now you can see that first and third column are same. So its value is 0 because column 1 and column 3 are same. So LHS is equal to RHS. Using property of determinant and without expanding, prove that this is equal to 0. See again, left hand side is 1, 1, 1, BC, CA, AB, A into B plus C, B into C plus A, C into A plus B. Here we want to show it is equal to 0. That means we will try to get any two rows or any two columns identical using properties. So here first of all we expand these brackets. So it is equal to 1, 1, 1, BC, CA, AB, AB plus AC, BC plus AB, AC plus BC. Now, second column I am adding in first column. So 1, 1, 1. Second column as it is. Second column we are adding in first column. So adding BC here, it will be AB plus BC plus AC. Add CA here, so it will be AB plus BC plus AC. Add AB here, so it will be AB plus BC plus AC. So what is done? Change is in third column. In third column, what is done? In third column, second column is added. A column in which we do change, that we show here. In third column we are doing change, so put here C3. And which change we are doing? So by this performing. In third column add second column. So that will be new third column. So this operation is performed. And when we perform this operation, value of new determinant remains unchanged. Given and new, it will be same. Now, from this determinant, in third column, AB plus BC plus AC is common. Taking common, that means what? Third column is divided by AB plus BC plus AC. See, third column dividing this by AB plus BC plus CB, AB plus BC plus AC, so it will be 1, 1, 1. Now, as we discussed in property, if any determinant is multiplied by k, then its value becomes 1 by k times. If any determinant is multiplied by k, then its value becomes k times given determinant. Or if any row or any column is divided by k, say in simple way, what I explained in this property, that inside if you multiply, outside divide. Inside if you divide, outside multiply. So here third column is divided by AB plus BC plus AC. So outside multiply by AB plus BC plus AC. So in looking this in simple way, it looks like that. From third column, this is common. So in simple language, we can say from third column taking AB plus BC plus AC common. From third column taking AB plus BC plus AC common, or this operation can be performed as third column. What is done in third column? Third column is multiplied by AB plus BC plus AC. Third column is multiplied by K. Third column is multiplied by K. So outside we keep here 1 by K. This is reciprocal of that number, because value of this determinant becomes K times. So to join them by sign of equality, we divide by K. In simple language, taking common. And now you can see that here first and third column are same. So this value is 0. So this is AB plus BC plus AC into 0. So value is 0. So here because column 1 and column 3 are equal, so LHS is equal to RHS. Now in this question, beginning from left hand side, left hand side is minus a square ab ac ba minus b square bc ca cb minus c square. See, here we will put sign later on. Look here, elements. Whenever you start from any given determinant, first of all, always observe that is anything common from any row or any column. If you find something common, then take it out. Say here, from first row, A is common. First row A is common, so A is taken out. So what is left here? Minus A, B, C. A is also common in first column. So we could also take A common from first column. So we could also put here minus A, B, C. But choose any one way. So here working in rows. Now second row, take B common. So B common. So what is left here? A minus B, C. From third column, C is common. C is common. So what is left here? A, B and A, B minus C. So here we join this by sign of equality. So whenever anything is common, we are allowed to take out. So what operation we perform here? Say change is in first row. What is change in first row? First row is divided by A. Inside divide, so outside multiply. Second row is divided by B. Inside divide, so outside multiply. Similarly, third row divided by C. So this is performed. That is ABC into. Now here, from this first column, again A is common. From second column, B is common. From third column, C is common. Once again. Now from column, A common. So A common. So A into A square. B common. B into B square. C common. C into C square. What is left? Minus 1, 1, 1. 1 minus 1, 1. 1, 1 minus 1. So what is done here? From first column, A common. From second column, B common. From third column, C common. Now these are very simple numbers. A square, B square, C square into. Now see what we do. Second row I am adding in first row. Second row adding in first row. This will be 0, this will be 0, this will be 2. Here 1 minus 1, 1, 1, 1 minus 1. So here what is done? Change is in second row. What is done in second row? First row. In first row, second row is added. So value remains unchanged. And now here in the first row there are two zeros. So using this first row, now we are expanding. Whenever we get two zeros in any one row or in any one column, after getting that step, expand determinant. So A square, B square, C square into, say here 2 into 1 plus 1. So 2 into 2, 4. So it is 4A square, B square, C square. This is RHS. So LHS is equal to RHS. So when we will do such type of problems, prove that whenever we find anything common from any row or column, then take it out, continue sign of equality. Or second important rule, any row or any column multiply by any number and add values in some another row or another column. So performing this operation, also value remains unchanged. So after performing this procedure, continue next step by sign of equality. Using properties, prove that LHS is equal to RHS. Beginning from left hand side, B plus C, Q plus R, Y plus Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. Beginning from left hand side, going to get right hand side. See here these 9 single entries. And whenever we prove this type of problems, before starting or on every next step, always check continuously on right hand side. Every time we are getting hints from right hand side that what to do in the next step. So here, first of all, so here numbers are B, C, C, A, B. If we add these numbers, second and third row, if we add in first row, second and third row, if we add in first row, then this will be 2 times A plus B plus C, this will be 2 times P plus Q plus R, 2 times X plus Y plus Z, then 2 will come out, this 2 will come. So that is starting. So here, adding second and third row, in first row, 2 times A plus B plus C, 2 times P plus Q plus R, 2 times X plus Y plus Z. Second and third row as it is. So which operation is performed in first row? In first row, second row and third row are added. Under this operation, this is done. Now 2 common. 2 is common. That means first row is divided by 2. So under this operation, first row is divided by 2. When inside divide, outside multiply. So A plus B plus C, P plus Q plus R, X plus Y plus Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. Now observe here, we want APX. We want APX. So this is unwanted part. B plus C, Q plus R. But here in second row, we don't have B plus C. Here also we don't have B plus C. So direct we cannot eliminate B plus C. Instead of that, what we do here, see, in first row we are subtracting second or third, any one. If we subtract, suppose third row, here I am subtracting third row. Subtracting third row in first row, then this part will be eliminated. A plus B, P plus Q, X plus Y. So doing this, third row is subtracted in first row. That means elements of third row are multiplied by -1 and products we are adding in first row. So this will be C. Here P plus Q will be cancelled, that is R. Here X plus Y cancelled, that is Z. So here C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. And what is done here? In first row, third row multiplying by -1 and added in first row. In short, from first row, third row is subtracted. So value remains unchanged. So we continue these by sign of equality. CRZ, say we have obtained this line CRZ, but in first place, not in third place. So that can be done later on. Now we focus on next remaining lines. Now see, if a CRZ, if these values are subtracted in second row, then CRZ can be eliminated. So what will be left? APX. The entries which are in first row. So doing by that way, first row we are subtracting in first row CRZ, subtracting in second row. So what is left? APX, A plus B, P plus Q, X plus Y. So what is done here? Change is in second row. In second row, first row is subtracted. So doing this operation, value remains unchanged. So we continue them by sign of equality. So see, APX is obtained. This line is obtained. Then BQY is left. BQY. So this can be obtained by subtracting the second row in third row. So now next step is 2 into CRZ APX. Now this line I am subtracting in third line. So what is left? BQY. So what is done here? Change is in third row. In third row, second row is subtracted. Doing this operation, value remains unchanged. So we have derived required numbers, but not in proper location. So now what we do? This line we need it last. So interchanging first and third row, and as discussed in property, when we interchange first and third row, see, third row is now first row, first row is now third row. Whenever we interchange first and third row, we change sign. If you interchange any two rows among themselves, change sign, because value becomes additive inverse. So CRZ is now in the required location. Now again observe right hand side. APX, this line we need here, and this line we need here. So we interchange first and second row. So once again, here interchanging first and second row, APX, BQY, CRZ. So first and second row are interchanged, and when we interchange this, we have to change the sign. Again minus is converted into plus, plus converted into minus, again minus converted into plus. So what is done here? Here first and second row are interchanged. Here first and third row were interchanged. So this is RHS. So LHS equal to RHS. By using properties of determinant, prove this LHS equal to RHS. So to solve this question, beginning from left hand side, 1 1 1 A B C, A cube B cube C cube. Now always before starting, check right hand side. What is given on the right hand side? Here on the right hand side, factors are given. So that means we want to factorize. Factorization, that means take common. So that means we will produce common in any rows or any columns, and we will take it out. So see, first of all, focus on A minus B. See, to get A minus B, here this is A, this is B. If I subtract second column in first column, then 1 minus 1 0, A minus B, A cube minus B cube, 1 B B cube, 1 C C cube. So what is done here? In first column, second column is subtracted. That means elements of second column multiplying by minus 1 added in first column. So change is in first column. Value remains unchanged. Doing this, here now you can see that in the next step, A minus B can be taken common. Here A minus B is common, it is visible. Now observe B minus C. This can be done here. So say, if we subtract third column in second column, that means third column in second column, then in the same step, here 1 minus 1 0, B minus C. So here I am putting B minus C, B cube minus C cube. In the same step, two operations at a time. In second column, third column is subtracted. So performing these two operations at a time, we are allowed. We can do this. So here B minus C will be common in second column. So now taking common from first column, A minus B common, from second column B minus C common. Now what is left in first column? 0 1. Here A minus B taken common, so what is left? A square plus AB plus B square. Here B minus C common, so 0, here 1, here B square plus BC plus C square. Third column as it is. So what is done here? From column 1 is divided by A minus B. Taking common, that means inside divide by A minus B. And column 2, we are dividing by B minus C. And say, doing this operation here, we are getting two zeros. And to get two zeros in any one row or any one column, getting two zeros in any one row, any column, it makes the calculation very easy. Now, these two are common. Now, still we need these two factors. So, one more can be taken common, doing some more operation in this same determinant. Now look, here if we take subtraction of suppose here if in the first column second column is subtracted, here we will get one more 0, here b square will be cancelled, here a square minus c square, so a minus c can be created, can be produced in this corner by taking subtraction of these two. See, once again subtraction, once again I am subtracting this second column in first column. So here 0, here subtract 1, so 0, subtracting this, so b square is cancelled. So what is left? A square, then minus c square plus ab minus bc. A square minus c square plus ab minus bc, b square minus b square cancel. So taken subtraction and arrange properly. This column as it is 0, 1, b square plus bc plus c square, 1 c cube. So here what is done, again in first column, second column is subtracted. So now see here we are taking common a minus b, b minus c. See here a minus b, b minus c, here 0, 0. Now see here a square minus c square plus ab minus bc, from this polynomial here a minus c, a plus c plus b common, a minus c common. So what is left? A plus c plus b. So factors of that left bottom corner we have taken here inside. So now here I am putting these factors, a minus c, a plus b plus c, 0, 1, b square plus bc plus c square, this is c square, 1 c cube. So a minus b, b minus c. Now a minus c common, taking a minus c common, say we are getting this, here this is c minus a, we are getting a minus c. A minus c can be converted into c minus a at last by changing sign. So here 0, 0, a plus b plus c, 0, 1, b square plus bc plus c square, 1 c cube. Out of 4 factors, if you produce 3 factors as common one by one from rows or columns, then last factor it will be produced from expansion. But before expansion always check, get 2 zeros in any one line. See, first row there are 2 zeros, first column also there are 2 zeros. So using first row or first column, now we are putting expansion. So using first row, expanding this, a minus b, b minus c, a minus c. Now expansion, 0 into anything 0, 0 into anything 0, 1 into product of these two numbers, that is 0, minus product of these two numbers, that is minus a minus b minus c. This is expansion. Using first row, 1 into product of these two numbers 0 minus product of these two numbers. So here we can put minus a plus b plus c. Now see, this is minus, I am changing this sign. So a minus b b minus c. Now this minus I am including in this bracket, so it is c minus a into a plus b plus c. This is RHS. So LHS equal to RHS. Say here no unique method. It's not necessary that I started by this action, that subtract second in first, third in second. You can also start this by this way also. See here 1 a cube, a cube, 1 b cube, 1 c cube. Here we did this action. This is subtracted from first, this is subtracted from second. Instead of that, if you subtract this third column in first, subtract third column in second, subtracting this from first, subtract this from second. This starting is also allowed. So doing this, here you will produce factor a minus c, here you will produce factor b minus c. So in the beginning what will be common? A minus c, b minus c. Here we obtained a minus b, b minus c. Instead of that you will get a minus c, b minus c. And third and fourth after a few steps. Or here you can also do this starting. You can start by many ways, no unique method. Suppose you want to subtract this column in second column, in third column, then here you will have b minus a, b cube minus a cube. So here you will have b minus a. B minus a, later on it can be converted into a minus b, as we did here. So a minus c is converted into c minus a. So b minus a can be converted into a minus b in the last steps. And subtracting this here, you will get c minus a. So a minus b, c minus a minus b, c minus a. So this will be out. This will be common. You can also do starting by this way. Say middle column, subtract in first column, in third column. So here you will have a minus b and here you will have c minus b. You can also start by this way. This column, subtract in this column, and this column, subtract in this column. See, look, patterns of beginning. You can do by this way, observe pattern. You can do by this way, second starting, third starting, fourth starting, fifth starting. You can start by different 5 ways. Not only this question, almost many questions, so many questions. You can start by more than one methods. So no unique method. Mechanism is common. Prove this question. Beginning from left hand side is x square yz, y square zx, z square xy. Always we get a hint from right hand side what we want. So look here, again there are 4 factors. So out of 4 factors, 3 factors can be taken common, one by one, producing from either in rows or in columns, as we did in last question. So see, first we focus on x minus y. X minus y can be produced by subtracting second row in first row. So doing this, here subtracting second row in first row, x minus y, x square minus y square, here yz minus zx. So from this x minus y will be produced common. Now in the same step we can also produce y minus z, for which we subtract this in second row. So third row now subtracting in second row. So y minus z, y square minus z square, zx minus xy, z square xy. So what is done in first row, second row is subtracted, in second row third row is subtracted. So this is equal to x minus y. Here factors are x minus y, x plus y. Here z is common, so inside there will be y minus x, but we want x minus y. So for x minus y, minus z common. Here y minus z, factors are y minus z, y plus z. Here minus x common, so y minus z. We are getting similar in all three places. Z square xy. And now say x minus y common from first row, x minus y common, y minus z common from second row, y minus z, y minus z, y minus z. So what is left here? 1 x plus y minus z. Here 1 y plus z minus x. Here z square xy. These are left. So say out of these three factors, first two factors are produced by choosing this starting. Here instead of subtracting second in first, third in second, we could also start by this way, that subtract second in third, first in second. We can also start by this way, subtract first row in second as well as in third, or subtract middle row in first in third, or subtract third row in second in first. 1, 2, 3, 4, 5 or more ways of starting. Sometimes you will get these two factors common, sometimes you will get second and third common, sometimes you will get first and third common, sometimes you will get with opposite sign. So such type of questions can be solved by many ways. Mechanism is same. We cannot say that these are different methods. Startings are different, but applying same rules. Now focus on this part. Now we want z minus x. Z minus x. So see, to get z minus x, here, see here, this is minus z, this is minus x. So what we do? First row, I am subtracting in second row. So this will be z minus x. Here we will get 0. And here y will be cancelled, z minus x. That will do. So it is equal to x minus y, y minus z, 1 x plus y minus z. Now first row I am subtracting in second row. So 1 minus 1, 0. From this number, if we subtract this number, y will be cancelled, z minus x. And here z minus x. So z square xy. So what is done here? Change is in second row. In second row, first row is subtracted. So it is done. So doing this, now z minus x is common, x minus y, y minus z, z minus x common. So what is left? 1 x plus y minus z, 0 1 1, z z square xy. Three factors are obtained. Now fourth factor, last factor, it can be produced by expansion, or sometimes it can be produced also as a common element in any one line. Now next step, if possible, try to get common element in any one row or any one column, but we can see that because it is xy, yz, zx, this is x, this is y. So better way is we try to get two zeros in any one line. So see what we do here. This is already 0, already we derived. This line I am multiplying by z and subtracting in the third row. So here I will get one more 0. So two zeros will be there in first column, and after getting two zeros, using that column we will expand. So first column multiplying by z and subtracting here x minus y, y minus z, z minus x, 1 x plus y minus z. Now 0 1 1. Now see, multiply by z, subtract here, so 0. Multiply by z, subtract here, so this was z square minus xz minus yz. Multiply by z, subtract here, so xy plus z square. This is obtained. So what is done here? Change is done in third row. So what is done in third row? In third row, first row is subtracted. First row multiplying by z. First row after multiplying by z, subtracted from third row. Now here, using this column we are getting expansion, x minus y, y minus z, z minus x. See, 1 into product of these two numbers minus product of these two numbers, that is z square minus xz minus yz. 1 into product of these two numbers minus product of these two numbers. Then 0 into anything is 0, 0 into anything is 0. So at last, try to get two zeros in any one column or in any one row. So this is x minus y, y minus z, z minus x. Here z square will be cancelled. So xy minus minus plus xz plus yz. So this is required RHS. So LHS is equal to RHS.